Hello, my name is Michael Newart and I'm an engineer and electrical contractor, and I do testing of electromagnetic fields for a living for over the last 20 years. One of the things I do in my work is I review test meters and sell and rent test meters to help people like yourself perhaps to do some of your own testing of electromagnetic fields in your home and office. And so this video is a review of the Tenmars TM-196 radio frequency test meter. This is a meter that costs about $300 typically. It's has some very good features, which I'll go over in a second. But basically, because of some quality issues, I feel that I cannot recommend this meter for purchase at this time. There are some serious issues with it, and I'll go over that also in a second. Some of the good things about the meter is that it has a wide frequency range, ranging from detection of fields at frequencies as low as 10 megahertz up to 8 gigahertz. These are the different frequencies of EMFs that are out there, and that's important because some of the common frequencies being used now include 5.8 gigahertz and 6 gigahertz for things like cordless phones in the home, Wi-Fi systems. And so the typical radio frequency meter that only goes up to around 3 gigahertz or 3.5 gigahertz will not detect these higher frequencies of 5.86 gigahertz. So this particular meter goes up to 8 gigahertz, and so that's a good feature of it. Another good feature is that it has a very good and high sensitivity to digital microwaves. Again, some of the meters out there have a little bit trouble with picking out the digital portion of the signal. These digital signals are signals that are pulsed off, on and off, and you need a meter that can detect the high points of these pulses and give you that high measurement and not just average the whole field out. If you average it out, you get a much lower measurement than if you detect the peaks. So this meter appears to be a pretty good one for measuring these peak of the values of the digital microwaves. But unfortunately, I feel I cannot recommend this meter for purchase and use because of some very serious quality issues. I personally have tested 3 of these meters. I'll show you the meter right here. This is the TM-196. I'll turn it on. Just a green button here, pretty simple. And I think you can see the numbers there. I'm going to set this right now with the unit button to microwatts per centimeter squared. And you can see there, let's get this front of the camera there if you can see that. You can see that. Right now, the level here in this office is 0.000 microwatts per centimeter squared. This is a very low field location. In fact, I use this office in this area for testing meters because there is very little interference from other sources here. So the problem with this meter is, and I've tested 3 of them, is sometimes you get erroneous high measurements from the meter, which someone like yourself, if you're not a professional, probably wouldn't even know. You'd assume you're measuring a field. How would you know that it's an erroneous measurement, an erroneous measurement of a high field? I know that because it happens here in my lab every once in a while. I'll be measuring in this zero field area and all of a sudden I'll get really high readings. And I've tested 3 of these. 2 of them have had this issue intermittently. I can turn the meter on and we'll see if we have a 0 right now. Right now it looks like, yeah, we're having a 0 in this particular setting. So that looks good. And that's the way it usually works. About 1 out of 10, 12 times that I will use these 2 that I've tested so far in my lab. The issue is that maybe 1 in 12 times, all of a sudden I get really high readings here. And I've had the same thing out in the field, near cell towers and other sources, where just sort of at random, every once in a while, maybe 1 in 10 times that I'm out there, I'll get some really high readings that don't make sense and are not corroborated by other meters. And so I've also tested a 3rd meter. It actually had very similar high levels, but that particular meter was high all the time. In fact, I found that out. A client of mine had one of these. I didn't know that this is what they had when I came out there. They had high fields, and that's why I went out, traveled to Nevada to take a look at their home, and the cell towers fairly nearby, and it turned out their readings were not near as high as the meter had said because they were getting these erroneous readings, but their meter read high all the time. In all these cases, when these 3 meters read high, they've generally been in the range of 100 and even more times higher than it should be, so very significant. And one of the reasons that I know it's a problem with the meter is that in a zero field here, when I get the high readings, I could get it for 5 minutes or so, and then all I have to do is turn the meter off and then back on again. And just like that, it would go back to reading properly again, and the readings would go back down to 0. So, and that happened several times, and then it happened with new batteries. So I know it wasn't a battery issue in this case. And I'm not sure what the problem was with the meter. Some of these electronics can be very sensitive to electric fields, both AC electric fields and DC electric fields, but they should not be that vulnerable, in other words. And unfortunately, someone like yourself, the average person, would not know that this meter is reading improperly. There's just no way of you knowing, basically, unless you're a little more of a professional and have a zero test area like I do. So I would not recommend this meter because the 3 that I have tested have all 3 had this high reading issue. 2 of them, it was intermittent, it just randomly, but seldom, but every once in a while, and the 3rd one was stuck at that level all the time. And another issue that I've heard of, this is not my personal issue with them, but from my distributor, I have also heard that a lot of people have complained about this, and they found that it has a low battery issue, where some of the meters, when the battery starts to get low, not so low that, say, the low battery light comes on and you have a warning to change the battery, but the battery is getting kind of low and already the meter is starting to malfunction. And so I've been told that there's some of that issue with this particular meter also. And the way you fix that, of course, is just put a new battery. But you should not have to guess that you need a new battery. The display should say new battery before the battery gets so low that you have that kind of quality issue. So that's the second reason why I probably not recommend this meter until the manufacturer makes some modifications, changes, repairs, whatever is going on with the electronics for the meter. So I would not recommend this meter at this time, and I'm hoping that the manufacturer at some time will do some improvements to the meter, repairs to it for this kind of problem, because I would like to recommend this meter to people, as right now this would be about the best meter for the $300 kind of price range. Pretty much all the meters that are less costly than this have other issues. So typically, at this point, I am still recommending the TES-593 radio frequency meter, which is about a $500 meter, very similar features, but has more accuracy, and I don't have this kind of erroneous high reading issue. It's about, so this $500 RF meter, the TES-593, sometimes also called the 8 gigahertz radio frequency meter, a couple different names for it. Sometimes you'll see other manufacturers put a name on it also. You can look at my website for it and see what it looks like, and it might help you understand which one it is. But that's the meter that I recommend right now, and unfortunately all the meters that are less costly than that have certain issues. For instance, they will often be only single axis rather than 3 axis, so you tend to undermeasure the strength of the field because you're only measuring 1 axis at a time. Some of them have more difficulty picking out the digital microwaves. The digital fields are a much harder thing for the meters to pick up than the old analog fields like AM and FM radio. The digital fields come out in little pulses, and the meter has to be able to detect these very brief pulses and give you an idea of what this maximum is while the pulse is high, and not average it out. If the meter's on only, say, 1/10 of the time, some of the meters will average that out. You'll get a measurement that's like 1/10 of what actually the full strength is when it's pulsing on. Good luck with that, and if you need any help with meters, one of the places to look are some of my websites, which is emfcenter.com and emfinfo.org. And a pleasure to talk to you today. Have a great day.